Welcome to McPlum, simple solutions served daily.
You start by fixing a coordinate system and units so numbers mean something. Once done, measure or read the initial position and the final position. You take those coordinate values and label them clearly as x0, y0, z0, and x1, y1, z1. Make sure to note orientation and sign conventions. This prevents mistakes later. Now compute the basic vector difference component by component to begin turning positions into displacement. You now perform the component-wise subtraction. Subtract initial from final for each axis, deltix, deltoi, deltas, and write those results beside your diagram. Once done, check signs to ensure direction is preserved. Negative means opposite chosen positive axis. If motion is along a line, keep it simple. If not, keep each component separate until final combination. Make sure to simplify arithmetic and you finish by converting components into the form you need. Compute magnitude with the square root of some squares and find direction with aten2 for proper quadrant, then express the unit vector if required. Once done, present displacement with units and a clear sign or angle. If numbers look wrong, recheck your coordinate origin, unit consistency, and measurement accuracy. This single troubleshooting check catches most errors and gets you back on track quickly.
Thanks for watching. Stay juicy and subscribe.